Hello, and welcome to Lesson 1. In this lesson, we will discuss connecting the Android devices wirelessly. By the end of this lesson, you'll be able to define the Android wireless APIs, explain the steps involved in network service discovery, describe the process of P2P connections with available Wi-Fi networks, and describe the steps involved in setting up Wi-Fi P2P service publishing and discovery. In this module, we will learn about the Android wireless APIs. These APIs enable communication between the Android devices that are connected to the same local network, and they also enable communication between devices that are not connected to the network but are present at sufficient proximity to each other. Network Service Discovery, NSD, enables an application to publish a network service or seek out a network device providing the network service with which it can communicate. NSD enables a wide range of applications such as sharing files between devices, playing games with users in the same room, receiving images from an NSD-enabled webcam connected to the same network, remotely logging into a machine on the same network. Most network API methods are asynchronous. Listeners are generally registered to handle responses. This means that an API call returns immediately without waiting for a response but passes a listener object. An Android system uses these listener interfaces to pass the response to the application. Note that all network operations involve unpredictable delays and hence should not be performed on the main thread. Several methods are available in Android such as background operations and helper threads. Now, let's discuss network service discovery, which involves the following steps. Registering a service on the network if our application is a provider of the service. Discovering services available on the network so that our application can check if it can communicate with the service provider. Connecting to a service on the network to start communication, unregistering the service before application closes so that no other devices can see the service. For the application to use network services, the application should declare the appropriate permission in its manifest file. In case of NSD service discovery, it is android.permission.internet. Registering the service is required only if our application provides a service. This has two steps. One is creating a registration listener object and other parameters, and the other is making an asynchronous API call to register service. The first step is to create a registration listener object that handles the registration event callbacks. NSD API uses the callbacks in this interface to inform the application about the success or failure or registration or unregistration of events. The service name is a string which identifies the service. Applications on other devices detect our service by using this name. For example, Simply Chat is a service name that provides a chat service. This name must be unique on the network. Service type is the one which specifies the protocol and transport layer the application uses. For example, http:/TCP specifies that the application uses HTTP protocol over TCP transport layer. Port number identifies a port for each address and protocol, through which the devices can communicate after establishing a connection. Discovery protocol should be used for connection. We use Domain Name Service-Based Discovery. International Assigned Number Authority, IANA, has published a list of standard protocols and port numbers. If you intend to use a new service type, it is recommended that you reserve a service type and port number with IANA. For demo purpose, we will obtain an available port on the device. A registration listener must implement the following callback methods. A reference to the NSD service info object is passed to all these callbacks in addition to other parameters wherever necessary. Let us talk about each callback method. OnService is called when the service is successfully registered on the network. OnRegistration is called when a failure occurs during service registration. An error code is passed to indicate the exact error. OnService is called when the service is unregistered successfully. An application that provides a service must unregister before closing. OnUnregister is called when some error occurs while unregistering the service. An error code is passed to indicate the exact error. To register our service, we get a reference to the system service object of type context.nsd_service. Then we build a NSD Service Info object for our Simply Chat service, which uses HTTP protocol over TCP transport layer. NSD Manager.Register service is called with parameters: Service Info object, the discovery protocol, in this case, domain name service-based discovery, and the registration listener. Let's talk about how we can discover NSD services available on the network. The process of discovering is very similar to that of registering. Here again, there are two steps: creating a discovery listener object and other parameters, and making an asynchronous API to call Discover Service. First, we have to create a discovery listener object that handles discovery event callbacks. The NSD API uses the methods in this interface to inform our application when the discovery is started, when it fails, and when the services are found or lost. Lost means it's no longer available. Service type specifies a protocol and transport layer to look for. Discovery protocol to use, and we use domain name service-based discovery. The discovery listener must implement the following callback methods. OnDiscoveryStarted is called when the discovery is started successfully. OnServiceFound is called when a service is found and passes the service info object corresponding to the found service. In this step, it is a good practice to check if the application discovered its own network service or if it is providing one. If a service we are looking for is discovered, we can connect to it. But before connecting, we must determine the connection information for that service by calling resolve service open bracket close bracket API. OnServiceLost is called when a service that was previously found is no longer available. OnDiscoveryStopped is called before stopping the discovery. OnStartDiscoveryFailed is called when the discovery fails and provides the error code that indicates the reason for failure. OnStartDiscoveryFailed is called when the stop discovery fails and provides the error code that indicates the reason for failure. This step, which is resolving a service, resolves the service that was discovered in the previous step. Once resolved, our application receives the IP address and the port number, which is required to make a connection to the device providing the service. To resolve a service, create a resolve listener object that handles a resolve event callbacks. NSD API uses the methods in this interface to inform our application when the service resolve operation succeeded or failed. The resolve listener must implement the following callback methods. OnResolveFailed is called when the service resolve operation fails. It provides an error code to indicate the reason for failure. OnServiceResolved is called once the service is resolved. Our application receives detailed service information, including an IP address and port number, using which the application can establish network connection to the service. After successfully resolving the service information, our application can connect to the service using the Android network APIs. Let's now discuss the importance of unregistering a service. If our application provides an NSD service, it is important to close it before the application is closed. Unregistering will help other applications from seeing the service as still available and trying to connect. Also, the service discovery must be stopped when the parent activity is paused, and it must be restarted when the activity is resumed. Our application should override appropriate lifecycle methods of the activity to start and stop the service broadcast and discovery as appropriate. For example, we could call register or discover APIs from activities on resume callback. Similarly, unregister and stop discovery from on destroy callback. P2P is an acronym for peer-to-peer. The Wi-Fi P2P APIs enable applications to connect to the nearby devices without the need for devices to be connected to a network or access points. Applications running on a device can find other devices nearby and begin connection and start communicating using Android Wi-Fi P2P APIs. Android Wi-Fi P2P APIs conform to Wi-Fi Direct certification. The range of Wi-Fi P2P is larger than that of the range of the Bluetooth range. Following steps are involved in setting up a Wi-Fi P2P connection between two devices. Set up appropriate application permissions. Set up broadcast receiver and peer-to-peer manager. Initiate peer discovery. Filter the list of peers. Connect to a peer. Disconnect peer connection. Let us discuss each step in the subsequent screens. We need to declare appropriate permissions in the application's manifest XML file for our application to use Wi-Fi P2P APIs. The following permissions are required. Android.permission.access_Wi-Fi_state. Android.permission.change_Wi-Fi_state. Android.permission.internet. Although P2P does not require an internet connection, it still uses Java sockets, which require internet permission. To use Wi-Fi P2P, we need to listen for broadcast intents that tell our application when certain events have occurred. In our application, instantiate an intent filter in Activity's onCreateCallback method and set it to listen for the following. Wi-Fi_P2P_state_changed_action indicates whether Wi-Fi P2P is enabled or disabled. Wi-Fi_P2P_peers_changed_action indicates that the available peer list has changed. Wi-Fi_P2P_connection_changed_action indicates the state of Wi-Fi P2P connectivity has changed. Wi-Fi_P2P_this_device_changed_action indicates this device's configuration details have changed. Get an instance of Wi-Fi P2P Manager by calling getSystemService and passing context.Wi-Fi_P2P_service and initializing the P2P Manager. The initialize call returns the Wi-Fi channel object that we use to discover peer devices. Create the broadcast receiver class that listens and handles the Wi-Fi P2P state changes. In the broadcast receiver's onReceive method, handle each of the above Wi-Fi P2P state change cases. Register the broadcast receiver and intent filter when the activity is active, that is, in the activity's onResume callback method. Initiating peer discovery. To start searching for peer devices nearby, call P2P Manager's Discover Peers mmanager.discover peers (mchannel) P2P Manager Action Listener mchannel is the Wi-Fi channel object received when you initialized the peer-to-peer manager. P2P Manager Action Listener is the listener that implements methods using which the Android system tells our application if the peer discovery was successful or failed. Wi-Fi P2P Manager.Action Listener object implements the following callback methods. OnSuccess is called to indicate the application that peer discovery started successfully. OnFailure is called to indicate the application that peer discovery failed with an error code that indicates the reason for failure. After we invoke the Discover Peers API call, any change in the peers is notified to our application via intent with action Wi-Fi_P2P_peers_changed_action. Our application should register a peer list listener object, which implements the following callbacks. Public void on peers available Wi-Fi P2P device list peer list is called when a list of peers is discovered by the system. We can iterate over the list and decide whom to connect with. Note that onPeersAvailable returns all the peers that are available now, including the ones that were discovered in the previous call. If our application is managing a list of peers, flush out our existing list and create a new one. The last step in establishing a P2P connection is selecting a peer and initiating connection. From the list of peers received via onPeersAvailable callback method, choose a peer, create a Wi-Fi P2P config object, and call connect from P2P Manager object. We get the device address from the Wi-Fi P2P device object. Wi-Fi protected setup is set to push button configuration, PBC. We pass the action listener object to the connect method, which implements callbacks to notify the connection result. Following are callbacks of action listener interface. OnSuccess is called when connection to the device is successful. The broadcast receiver we created earlier will receive an intent with action. Wi-Fi_P2P_connection_changed_action when the connection is successful. On failure is called when the connection attempt fails with an error code that indicates the reason for failure. Earlier in this lesson, we learned how to broadcast network services, discover, connect, and communicate with devices offering known services between devices that were connected to a network or access point. However, Wi-Fi P2P service discovery allows us to publish services and discover services of nearby devices directly without the need to connect to an access point. Steps involved in Wi-Fi P2P service discovery are quite similar to those in network service discovery. Following steps are involved in setting up Wi-Fi P2P service publishing and discovery. Set up appropriate application permissions. Create a local service and register it if your application is providing service. Discover nearby devices that offer Wi-Fi P2P services. Connect to a peer device and begin communication. Let's look at the steps in the subsequent screens. As you are familiar by now, following are the permissions required. Android.permission.change_Wi-Fi_state. Android.permission.internet. Although P2P does not require internet connection, it still uses Java sockets, which require internet permission. Create a local service and register it if our application is providing service. Create a Wi-Fi P2P service info object. Populate it with information about your service. In the current example, we create a hash map of parameters that we use to create Wi-Fi P2P service info object. A hash map is a collection of key value object pairs that the discovering device will receive. The receiving application is expected to know the keys and extract values to determine the exact service offered. Wi-Fi P2P DNS-SD service info represents Wi-Fi P2P or Wi-Fi Direct Service Info class, which is used to broadcast P2P services. The first parameter to new instance is the name of the service instance. In this case, it is _simply P2P. The second parameter is a protocol name .transport layer. The last parameter is the hash map of key value pairs. mmanager is an instance of Wi-Fi P2P manager by calling getSystemService and passing context.Wi-Fi_P2P_service and initialize the P2P manager. mChannel is an object returned by the Wi-Fi P2P manager initialize call. Action Listener is a Wi-Fi P2P manager.actionListener object that implements the following callback methods. OnSuccess open bracket close bracket is called to indicate the application that peer discovery started successfully. OnFailure is called to indicate the application that peer discovery failed with an error code that indicates the reason for failure. Discover nearby devices that offer Wi-Fi P2P services. Set up listeners to receive service response and service records broadcast by service providers. DNS-SD Service Response Listener implements following callbacks. On DNS-SD service available is called with the actual description and connection information. DNS-SD Text Record Listener implements following callbacks. On DNS-SD Text Record Available is called with hash map of the service published by P2P Service Publisher that we learned earlier. Along with the service hash map, device info structure is also passed. The receiving application can maintain a list of available devices and services offered by them. This can be presented to the user via a user interface to select a service to establish connection. Call Add Service Request to start receiving service responses to Service Response Listener. Call Discover Services to start receiving service records to Text Record Listener. mChannel is the channel object returned by Wi-Fi P2P Manager initialize call. Action Listener is the Wi-Fi P2P Manager.ActionListener object that implements following callback methods. OnSuccess open bracket close bracket is called to indicate the application that peer discovery started successfully. OnFailure is called to indicate the application that peer discovery failed with an error code that indicates the reason for failure. The last step in establishing a P2P connection is to select a peer and initiate connection. From the list of peers, choose a peer, create a Wi-Fi P2P config object, and call Connect from the P2P Manager object. This is similar to the Wi-Fi P2P connection which we discussed earlier. After connection is established, devices can communicate using a known protocol such as sending print request to printer. Let us summarize the topics covered in this lesson. In this lesson, we defined the Android wireless APIs for wireless connections. We discussed how to discover the network service. We explained the steps to register the service. We explained the steps in resolving a service on the network. We listed the key points in unregistering a service. We described the P2P connections with Wi-Fi connection setup. Finally, we described the steps involved in setting up Wi-Fi P2P service publishing and discovery. This concludes the lesson on connecting devices wirelessly.